had a huge party and invited all our biking friends and their younger siblings. Some kids were too young for two-wheelers and rode their tricycles. There were 84 wheels and 33 seats. How many bicycles? How many tricycles? So, a picture can help us figure out this problem. You can see here that a white circle represents a bicycle and a shaded circle represents a tricycle. We know that there's 33 altogether, so let's just assume at first that all of these 33 white circles are bicycles. So we'll do 33 times 2, and that's 66, and that's not enough wheels. So let's add some tricycles. If we add 3 tricycles, then that's going to be 30 bicycles. 30 bicycles have 2 wheels, so 6. And then 3 tricycles with 3 wheels each is 9. So that's 69 wheels, and that's not enough. So let's add some more wheels here. Add some more tricycles. 9 tricycles leaves, let's see, 1, 2, 3, 4, 24 bicycles and 9 tricycles. Times 2 is going to be 48. Times 3 is going to be 27. 48 plus 27. 5, 1. 75. We're getting closer. So we need 84 wheels and we have 75 wheels. So every time we add a tricycle, we add a wheel. So we need to add 9 more. Let's try adding 9 more wheels. 9 more tricycles. 1, 2, 3, 4, 5, 6, 7, 8. Oh, those got sloppy. 7, 8, 9. Okay. So that leaves 6, 12, 13, 14, 15 bicycles and 18 tricycles. Is that correct? Yep. So multiply that by 2 and get 30. Multiply that by 3 and get 4, 2, 54. 54 plus 30 is 84. So we need 15 bicycles and 18 tricycles. Another way to figure out this problem is to do guess and check. So you start, okay, so we already know that we need 15 bicycles and we need 18 tricycles. So the point to this is not to solve this again, but to show you another way to solve it. So if you didn't know, you could say, well, we need, let's say we start with 20 bicycles, and that would leave 13 tricycles. Bicycles times 2 is 40. Tricycles times 3 is 39. 40 plus 39 is 79. And that's too low because we need 84 wheels. So adjust your guess just a little bit. You know that you need 84 wheels, so let's increase the number of tricycles and decrease the number of bicycles. So let's go to 15 bicycles, and that would make 18. I'll see, I went right to the right answer. Let's change that just a little and pretend that we don't know, and we'll go for 13 bicycles and 20 tricycles. 13 times 2 is 26. 20 times 3 is 60. That's going to be 86, and that's a little bit too high. So adjust your guess to 14 and 21. So you get 20. 14 times 2 is 28. 21 times 3 is 63. So that's going to be what? 28 plus 63. 91. That's too high. So 15, 18, 30 plus 54 is 84, and that's the guess that we're looking for. So there's 2 examples of how you could solve this problem. Now here's an example that's a little bit more involved with math. So what you need to do is write 2 equations from the problems from the story. So you could use the chart from the previous screen to help us. We know that we had total number of wheels and a total number of bicycles and tricycles is 33. So those are going to be our totals. 33 bicycles and tricycles and 84 total wheels. So if we have bicycles equal x and tricycles equals y, we know that bicycles plus tricycles equals 33. And we know that bicycles have 2 wheels and tricycles have 3 wheels. Now you need to convert both equations to slope-intercept form. So slope-intercept form is y equals mx plus b. You have the slope, and you've got your y-intercept. Okay, sorry that got sloppy. So let's convert these both to a slope-intercept form. Subtract x from both sides from that first equation, and you get y equals negative x plus 33. That's in slope-intercept form. And now let's subtract 2x from this side and 2x from this side. So 3y equals negative 2x plus 84. Now divide everything by 3. So you get y equals negative 2/3 x, and do 84 divided by 3. Looks like 28. So this equation here is in slope-intercept form, and this equation here is in slope-intercept form because they both have the form y equals mx plus b. Now our goal here is to graph those two equations. So let's start with this one here. So we know that the y-intercept is 33. So that means you put a dot right up here at 33. And we know that the slope is negative 1 over 1. That's our slope, so we go down 1 over 1. So did I do that correctly on this graph? Down 1 over 1, down 1 over 1, down, over, down, over, down, over. Okay, so the slope stays the same all the way down. Now look at the other equation. The y-intercept is 28 and the slope is negative 2/3. So you need to put a point at 0, 28, which is this point here, and then go down 2 over 3, 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 and the point where they intersect is 15, 18. And remember that x was bicycles and y was tricycles. So the point of intersection is actually the solution for the system of equations. Another really cool way to check the graph is to use this graphing calculator app called Desmos. And our equations were y equals negative x plus 33, and another quick peek will tell us what our other equation was. Y equals negative 2/3 x plus 28. Y equals negative 2/3 x plus 28. And here it shows you that the point of intersection is 15, 18. So you can draw a picture, you can do guess and check, you can do graphing, you can also do substitution. Substitution, you start with both equations, x plus y equals 33, and then 2x plus 3y equals 84. Then you convert the simpler equation into slope-intercept form. So that means subtracting x from both sides. Y equals negative x plus 33. Now you'll notice that this section of the equation, negative x plus 33, that's the same as y. It equals y. It's mx plus b. So we're going to use this chunk right here to insert into the other equation. So instead of writing y in the other equation, we're going to put negative x plus 33. So we're substituting this value in for this variable y. And here's how that works. 2x plus 3, parentheses, negative x plus 33 equals 84. So this chunk right here is the same as this here, and we know that they're equal to y, and this equaled y. So all we're doing is substituting part of one equation for another part to make it so that we only have one variable in the equation. This equation here only has one variable. It only has x in it. This equation here has two variables in it. So now distribute 2x minus 3x plus 3 times 33 times 3 is 99 equals 84. Combine those so you get minus x plus 99 equals 84. Minus 99 from both sides. Negative x equals negative 15. So we need to divide both sides by negative 1 to get rid of that negative in front of the x. So x equals 15. And then take this 15 and put it back into this first equation. So 15 plus y equals 33. Subtract 15 from both sides, and you get y equals 18. And again, that same solution, 15, 18. My favorite method is called elimination, and it's the last one that I'll show you here. The steps for elimination are to write the two equations from the story with the x and y variables lined up. So we have 2x plus 3y equals 84, and then we have x plus y equals 33. Now, change the value of one of the equations so one of the variables will cancel. So if you look at the second equation, this equation here, we know that there is a 1 in front of the x and there's a 1 in front of the y. Let's multiply this second equation by something so that we can cancel one of the variables. 1 and 2 are pretty close. So let's multiply this bottom equation by negative 2. If we multiply the bottom equation by negative 2, then we're going to change the value of everything inside that equation. It needs to all be multiplied by negative 2, so distribute to the x, and to the y, and to the 33. So our original equation, the top one, is 2x plus 3y equals 84, and then negative 2 times 1x is negative 2x. Negative 2 times 1y is minus 2y. Negative 2 times 33 is negative 66. Now, you see here that the x variables will cancel. 3y minus 2y is y, and 84 minus 66 is 18. Now put this 18 into the original equation. X plus y equals 33. So x plus 18 equals 33. And then subtract 18 from both sides, and it gives you the value for x. X equals 15. So that shows you that we reached the same conclusion as we did with the other methods. The different methods have different strengths and weaknesses, but if you know how to do the different methods, then you can choose which method you want to do to solve the problem. Thanks for watching.